Guys, today I'm going to talk about the articles of the top 5 ways medical physics has changed healthcare. So today we'll explore the transformative role of medical physics in healthcare, as highlighted by the American Association of Physicists in Medicine, the AAPM. While summarizing the content, I will also critically examine the article's perspective, so let's continue. So for the particle accelerators, the AAPM celebrates particle accelerators like linear accelerators and gamma knife system, which enables therapies such as intensity modulated radiation therapy, the IMRT. These technologies allow precise tumor destruction while sparing healthy tissues. For instance, the gamma knives use the cobalt-60 decay to deliver gamma rays exemplifies how physics-driven precision saves lives. However, the article overlooks significant barriers. IMRT and proton therapy require immense infrastructure and costs, limiting accessibility in low-resource settings. Additionally, while the AAPM emphasizes dose precision, it downplays long-term risk like secondary cancers from scattered radiation, which mentioned in the topic of ionization in lectures. The article also highlights that MRI and CT advancement for early tumor detection, aligned with lectures' explanation of X-ray attenuation coefficient and MRI physics. For example, dense tumors appearing lighter on scans. They are now replaced with sensitive film stocks and finally with digital imaging. As each of these newer technologies were introduced, doses to patients were reduced and the sensitivity of the techniques for finding early and treatable diseases increased. Yet the AAPM's optimism about MRI's universal adoption is questionable. MRI's high cost and operational complexity, coupled with limited availability in rural areas, are glossed over. Furthermore, while the article praises MRI sensitivity, it neglects the challenges like false positive in younger women. The AAPM also described the use of PET scan to image metabolic activity in order to monitor the effectiveness of cancer treatment. As shown on the PowerPoint, this process is explained both in the articles and during lectures. It involves matter and antimatter colliding each other. This process emits particles known as positrons. These positrons rapidly encounter electrons, collide, and also produce a pair of gamma photons which move in the opposite directions. These photons can be captured by crystal, and a 3D image is produced by computer techniques. However, while PET scan excels in imaging glucose metabolism, its limited spatial resolution compared to MRI and CT remain unaddressed. For CT safety, the AAPM 2008 guidelines for CT dose standardization are a commendable step toward patient safety. By advocating dose reduction technologies, the report acknowledged the risk that ionization models won on the lectures. Yet the article assumed uniform compliance and expertise across hospitals, which is unrealistic. Many facilities, especially in underserved regions, lack resources to implement advanced dose reduction tools. The AAPM also honors the milestone of discovery and development of different technologies, which has been widely used by people nowadays to save millions of lives. However, the article framed these advancements as purely physics-driven, underrepresenting the interdisciplinary collaboration required. MRI clinical adoption, for instance, depending on biologists, engineers, and clinicians working alongside physicists. The synergy is absent in the article. Similarly, CT success also relied on computational advancement beyond traditional physics. So in conclusion, the AAPM reports celebrate medical physics' monumental achievements from antimatter imaging to cancer sapping accelerators. Yet, its optimism occasionally overshadows real-world challenges like cost barriers, logistical complexities, and more. As we applaud these innovations, let's also advocate for equitable access and interdisciplinary humility. After all, the future of healthcare lies not only just in brilliant physics, but in bridging the gap between labs and communities. Thank you, and this is my presentation.